That's the field I wanted to get into.
Okay, good morning, good afternoon, good evening, everyone, wherever you are. My name is Vince LeCour. I'm the Vice President of the International Society for Geomorphometry. And today it's my pleasure to host our Coffee Talk speaker. So just before we start with the talk, I wanted to give a few slides about what the society is. So you are probably all well aware that geomorphometry is the science of quantitative land surface analysis. But what is the International Society for Geomorphometry? It's a non-commercial, non-governmental association of researchers and experts that is open to the free exchange of knowledge and opinions about various aspects of digital elevation models processing. The goal of our association, of our society, is to improve the understanding of the properties of the land surface as analyzed quantitatively from digital elevation models and from digital or paper maps. And it's also to advance the techniques used in terrain analysis. One of our goals is also to foster international collaboration in the quantitative analysis of the land surface, which is why we're hosting those coffee talks like today. And finally, we want to facilitate communication between scientists and students. We want to advertise relevant conferences and make available public domain datasets and scientific paper. So if you're interested in our society, if you're not already following us, well, we have a biannual conference. We're going to have one this year, this summer. I have another slide on that in a couple of minutes. We also organize sessions regularly at the European Geosciences Union meetings, General Assemblies, and at the American Geophysical Union meetings. And virtually, we're all over the internet. We have a website, we're on all the social medias, or many of them. And we have those coffee talks that we host bi-monthly. So what are the coffee talks? Well, it's a meeting like this one today that we hold between our main biannual conferences. The goal here is really to discuss, exchange, initiate, train, present, outline topics, show research agendas, papers, and ask questions. So we're only going to take 60 minutes of your time today. Our speaker is going to give a 15 to 20 minutes presentation, and then it's really just an open discussion and exchange that will be going. So you're going to have a chance to share feedback, to ask questions, and so on. So we're going to have another one in 2 months. So please promote the event in your networks when we're going to share the announcement for it. And finally, I just want to remind you all that our conference is coming this summer. It's going to be hosted by some of our colleagues in Romania in the month of July. So look for the event on the website. We're going to open registration very soon, and we hope to see many of you in Romania. So now I will invite our guest, Peter, to share his screen and to present what he has to tell us about today.
So first the mic test, you hear me? Hello?
Yeah, Peter. We can hear you, Bill.
Okay. Vince, you hear me as well, right?
Yeah, I hear you. I hear you. It was on my end. My headset wasn't on. Sorry about that.
You also see my screen, right?
We don't actually. Okay, now it's coming.
It's coming?
Yeah, now we see it.
Is it the right one?
Yes, it looks like it, yeah.
Very good then. Move this one over here. Okay, so thanks for having me to the Geomorphometry Coffee Talks. My name is Peter Strobel. I work for the European Commission's Joint Research Center located in Italy. And I'm going to tell you today about an activity which is called DEMIX, and that is the Digital Elevation Model Intercomparison exercise. As you can already see from the front slide, there is the logo here on CEOS. That is actually the committee that hosts this. I will come to that in a minute. But let me first get back to, is it changing? Yes. To the origins of DEMIX. How did this all get together? In about 4 or 5 years ago, the Copernicus program, which some of you might have heard of, that's the Earth observation program of the European Union, which is governed by or led by the European Commission, and of course in close collaboration with the European Space Agency and other entrusted entities. They were starting looking closer at digital elevation models, because running an Earth observation program is hardly possible without having a good elevation model. And we felt that we, at this point in time, had a need for something that really we could use across the whole program. And of course, the first question then is, which one is the best? Which one should we look at? Which one should we adopt? And so the idea came up for benchmarking DEMS, and we organized a workshop in 2019, where already some people from the ISG were involved. And we essentially concluded that we needed a coordinated approach, and we needed a consolidated method to compare DEMs and to give recommendations on which DEMs to use. And for that, we decided to bring the CEOS terrain mapping subgroup and the ISG together in order to form a consortium that could do that. So normally at this point, I explained what ISG is, but this way it's the other way around. So CEOS actually is the Committee on Earth Observation Satellites, and that is a group of essentially collecting all major space agencies worldwide. So those are the providers of all the satellite data that you know, and of course a large amount of the elevation models are based on these. And they are around for about 30 years now. They basically assemble all the major players in the field. And they are organized in different working groups. As you can imagine, this is a fairly large organization, meanwhile, pretty heavy bureaucracy and administration around. So you can see some of the recent groups and chairs there. And there is one working group there that looks in particular into data quality. That's the working group on calibration and validation. And this one, and I go quickly through this, as you can later look at this in more detail if you're interested. They have several subgroups, and one of them is called the terrain mapping subgroup. And this historically was dealing with elevation models in the past decades, but had basically been relatively idle for a couple of years. And we decided together with ISG to reactivate that, with the main aim to perform this DEMIX exercise. So we had several meetings, and we basically agreed that we want to have an exercise here with the main expected outcomes around DEM definitions and terminologies. It was actually also myself who insisted that we first should really make sure that we have a shared idea of what we actually are talking about, so that our terminology is not ambiguous. And then we wanted to get into benchmarking metrics and algorithms, and if possible, do as much as possible open source, so that we could get a comprehensive set of tools and a good method to compare DEMs, to basically then do the work, compare actual DEMs, the ones that we identify as candidates, and come forward with recommendations regarding which ones to use, and of course, ideally for author rectification. That is one of the main purposes for elevation models in CEOS, definitely. And then, of course, final reports, peer reviews, all these kind of things that you expect. What we did is we called through the ISG and through CEOS for participation. That you can see that happened in about a year later. That was around mid of 2020. We got in the order of 40 to 50 people that registered for it. We had a kickoff meeting with some 26 participants, I think, were at that. And since then, in the order of 15 to 20 participants with varying intensity were active on the different subgroups. of which we decided to install 3, one on terminology and analytical basis, one on algorithms and software, and one's on platform and processing. And of course, we also were looking at giving the whole thing a timeline, and we thought that could be, or I was hoping we could do it in more or less a year, which turned out to be way too optimistic. So it took us more than 2 years. Now, I would say we pretty much are there. And then, of course, the main first thing to do was to identify which of the DEMs we are going to look at. So what are going to be the candidates? And there were the 5 obvious ones. I mean, the first 4 were there when the activity started. The Copernicus DEM basically joined immediately after we had started, came out more or less at the same time. And then in the meantime, also FabDEM was added. I don't think I have to explain all these DEMs to you. This is stuff I'm pretty sure you all know, and most of these you will have hands-on experience. So those were the ones that we wanted to focus on. Of course, I like this because when you look at these in a standard way, you won't see much differences. But back to the DEMIX exercise, the first about 6 months were really spent on discussing about what is it that we want to do. How can we make sure that we have a consistent terminology across not only this exercise, but maybe also helping a little bit the domain in sorting a couple of things out that are historically ambiguous. So we were defining the DEMs. I'm also not going to spend much time on this. We were agreeing that we want them to be grid-based. That is an important feature, and we will come to the consequences in a minute. We were very much aware that there is, when we talk about elevation models, there are different elevations, different surfaces, topographic surfaces, which you can describe. So we needed to define the different spheres and the interfaces they have as the critical phenomena that we want to describe with our models. We had to look very closely then into how these different spheres would distinguish from each other. There are some interesting aspects that we discovered along the way, like I think it should always be emphasized, especially if you look at digital terrain models, that these models are abstractions. They sometimes, in the digital terrain model is a very clear example. They have areas in which they simply are not defined. Like underneath a building, there is not really a natural feature that you could use as for the model. So there will be points that you will need to interpolate according to some definitions, and essentially in these parts they will be conceptual. So it will be very hard to verify them in these locations because in reality they are not really existing. Another important point that is often overlooked or just kind of sidelined in elevation model, digital elevation model work is the very different nature that grids can have. And I think I wanted to bring this up here, even though that costs me a precious minute, but always be aware that points where the values only sit at the nodes are very different from grids where the values essentially represent the cells. These two things have very different consequences, and they should not be mixed up. So we also had put that. Resolution is a major factor. I think that is something you will probably be familiar. So we also wrote about this. We excluded certain things from being DEMs. So you find a list here. And I'm not going to go into all details because this has nicely been written up in a paper that was published. There is the DOI, and I think many people have read that in the meantime because it's very popular and a very good reference for the work in this domain. We continued with looking into algorithms and software. So how to describe a DEM, and there are many different criteria that you can use. So what we did in the first phase when this group was working was essentially making sure that things like slope or aspect, that the linear difference measures, that we compute them in a harmonized way, that we have an agreed way in terms of the formulas of the tools, how you can assess them. And we also were thinking about additional criteria, things like completeness of a DEM. So what is it? Are there any holes in it? Are the original data replaced by other data? Because we later also wanted to use those for comparison. Of course, having characteristics alone is not enough, because in the end, an intercomparison is only useful if you can get to a ranking, if you can really give the user recommendations of what you would recommend more than others, how you basically recommend the use of the individual DEMs that are as choice. And of course, such a recommendation should not be a generic one, because mostly people don't work everywhere on everything. So they have to be configurable, and they should be adaptable to the respective problem in question. And that was pretty challenging. And what we came up with was the so-called wine contest. That is a statistical method. As soon as you have criteria which you can rank, you can combine them using the wine contest approach in many different ways, so that you can find out whether there is, based on all these different criteria that you consider relevant for your case, whether there is a clear winner in this or not. So there is a quick scheme here how that works. Let's assume you have 3 candidates, and sometimes you have a reference, meaning something that you consider better than all the 3 candidates against which you test. Then you can do evaluations in a quantitative way, like the famous differences, but you can also look at derivatives like slopes, what we just saw. You can apply a lot of different criteria, and you can evaluate basically the candidates against those, giving you just some numbers, like the RMSE or the difference in slope. And out of those, usually you're able to create yourself an opinion. So the bigger the difference, the worse the candidate, or the smaller the better. And you can start ranking them. You can start basically giving them an order. This is what we call the opinion table. And that, of course, you can do in different areas for different criteria. So you can build quite a lot of these opinions with a few data sets. If you have a set of criteria and a set of areas in which you want to test, then you will end up with a fair amount of these opinions. And then the wine test contest actually steps in. You feed that into these statistics. And these will essentially allow you to sort out first of all whether there is really a difference between them, meaning whether these criteria are able to distinguish in a significant way the different candidates. You will be able to retrieve a ranking, an overall ranking of all the candidates, and you can make sure that this ranking is significant, meaning that there is not the differences are not so small that they would need to be in the end considered equal. And what you see here on the right, on the lower right, is an example of a final ranking in which you find that candidates B and C more or less perform equal. So there is no clear winner here, but there are 2 which are tie, and there is one which is clearly inferior, which is in this case candidate A. That was the theory. We found that this is a very good that this very well suits what we wanted to do, because it has a sound statistical basis. We can basically feed it with all the criteria that we want. It provides us a confidence level for the answers, which is very important as we want to give really recommendations on that. It's very adaptable. People can choose whether they want to have certain criteria considered or only in certain areas. So there is a wide range of flexibility. But of course, we also wanted to see how that works in practice. So we started with a 134, what we call DEMIX tiles. That was also part of the work to think of how can we essentially cut the globe into a number of test areas that are more or less equal size, which we can then use for these tests. Because of course, initially and probably for some time, we cannot run all the tests everywhere worldwide. That would be quite and for the main reason maybe that we don't have reference data everywhere. but we think we got a relatively good and representative selection here of landforms, of land cover types. All this was taken into consideration also when sorting out the criteria. And then we did pixel by pixel comparisons of the reference versus the candidate data. We had 15 different criteria and 3 classes. And altogether we had about 18,000 different of what I just showed you, opinions, meaning individual rankings on specific criteria in specific area. And these we could put together in the wine contest. And of course, we were very curious of what would come out. And the outcome actually is that we can very clearly say that at least overall, there are 3 DEMs that stick out in terms of quality. This is the ALOS, the AV3D30, the COPDEM, the Copernicus DEM, and the FABDEM, which is a derivative of the COPDEM. I did not yet, in this talk, it would be too much to go into the detail of, we did comparisons of DSM versus DTM. And in the end, it doesn't matter too much for the ranking here because we found out that many anyhow are kind of an in-between, but that's again a different aspect. What we also found is that very clearly SRTM and NASADEM are inferior in almost all of the criteria. They distinctively perform lower, and AsterGDEM really drops out in the sense that it almost always performs last. So this is clearly a model that on average globally you could not recommend to be used. Of course, results do depend on criteria and area. As I said, there are exceptions. There are areas in which you will find SRTM or maybe even Aster to be superior to the others, but those will be rather the exception. And of course, you have to be always careful when you are interested in a very specific area, whether the data that you use there in a given model, like the Copernicus DEM or the AV3D30, actually comes from that sensor, from the main sensor of that DEM, because sometimes it might also be just a fill-in. The ranking tool, I think I'm running out of time, so I will not say too much. Essentially, the ranking tool is the instrument that will allow to mix the different criteria and the different areas. So it will be something that we intend to have online so that people can basically do their own rankings, eventually also supply more tests. We have, I think, really very nice paper out on all this, which is currently submitted and is in the peer review, but there is a preprint available for which I showed you here the address where you can get it. Let me briefly say a few words about the more technical aspect of the platforms. We had also a working group that was looking into how can we put those things on a cloud, how can we make all these tools and data available to a broader public, how can we make, for example, the access to reference data easier. And that was sponsored by ESA and implemented by Visioterra in their VT Web platform, which also showed to be a very good tool for having these things interactively displayed. They also, of course, there is publications there. There is some examples here of they looked very closely into things like resampling and how really comparisons can be then performed in practice. On the upper right side here, you see a little sketch of what this DEMIX grid looks like in practice. But let me get out of this and into the outlook. So where will all this lead? We are currently finalizing the work on this subgroup 2. I hope the peer review will be closed soon, and then it's about time to wrap this up. We will consolidate maybe the web platform, so to have certain services available there, and then the TMSG will convoke a plenary to present all these results that will go in more detail than what I have shown you today. And we will have to discuss ideas on what we're going to do in the future, and because I think the cooperation is such, and TMSG has shown to be very productive, and also the work I think is very well taken. So DEMIX Reloaded, MER criteria, we should look more in detail to ortho rectification, which we have not yet done so. And so there is still some work to do that. CEOS is interested. We should eventually look into ground control points because, of course, DEMs are usually used in conjunction with imagery and for ortho rectification. And so it's important that these match. So there would be a demand also in seeing that we get worldwide to reference geometries, 3D reference geometries where we have imagery and DEMs matching. And those are possible things to do in the future. In the beginning, it was already said, but a bit more commercials for the Geomorphometry 23, which will host the next DEMIX workshop and also a TMSG plenary. Everything is going to take place within the same week at the same place. There are some links here where you can get further information or subscribe if you're interested. And with that, I thank you very much and conclude. And I think I'm a little bit over time, but I hope I haven't taken too much.
Thanks, Peter. Don't worry about the time. It was great presentation. I mean, it's an impressive effort, and I think that the outcomes of that effort will really benefit everyone in our community. So thank you for that. So now I will open the floor to comments or questions. You can either turn on at the bottom of your screen, you should be able to see a reactions button where you can raise your hand, or you can share comments in the chat, and we will moderate the conversation. Quinn, you can go.
Okay, thank you. Hi, Peter.
Hey.
It's great to hear your very good presentation, and great to see there's a lot of proceedings from the DEMIX project. I remember in 2019, at the beginning of this project, I'm very happy to join up. But sorry, I didn't keep the following up for this project due to some reasons. And actually, I have a question about the comparison among different global DM. It's about temporal issue, because I think actually for each individual DM product, actually there is a time stamp for the product. Like for example, for each individual location, maybe the result from the 2 VM, the record is all correct, but for the different temporal record, because the screen may have some change. So I'm not quite sure if the current comparison among different DM with different timestamp can be considered on this issue. I think this problem may be more significant for some merged global DM products, especially merged from different kinds of DM products. Thank you.
That's certainly a very pertinent point. We all know that in the end, the digital surface model or the surface as such is dynamic, and it's dynamic in many different ways. It's dynamic in a seasonal way. That's what we see on agricultural areas. It's dynamic in a let's say multi-year way, which we see in forestry, and it's dynamic also in urban areas over even longer time frames. So yes, it should be taken into account. On the other hand, in the resolution, meaning this 1 arcsecond class in which we currently work, these differences in many areas are still, let's say, over the decades that we have. For example, in forestry, as long as it's not a clear cut, the forestry growth, also we can see it over 10 years, is still not largely exceeding the accuracy of the DEMs overall. So it's not an effect that kind of invalidates reference data. What you should always have a look at is whether your reference data come more or less from the same epoch as the data that you compare with. If this is not the case, you of course cannot expect that they match 100%, especially if the respective land cover is a dynamic land cover. And in this sense, yes, it is an additional aspect. In the wine contest, it's mainly covered by the fact that we have tried to get a land cover considered, so that you can filter the results for different land covers. And if you are interested in at least getting this effect out, you can of course go for bare surfaces where this effect is usually the lowest. But generally speaking, of course, that is something to keep in mind, yes.
Thank you.
Great. Do we have any other questions? We have a comment in the chat that just says super interesting. Thank you. So anyone else has a question or a comment from in the chat? I see Sam unmuted for a second. Or Giuseppe?
Hi, Peter. How is it going? Yeah, I have a question. So far, the wine contest that has been done for ranking the digital elevation model give, for what I understood, give a ranking, consider, okay, in this area, this is the best, and so on the others, and they're following up the others. But there can be some cases that the ranking should be done at pixel level, where, you know, in some area, some digital elevation, but some pixel can be good, and some other area can be from another digital elevation model. So how you're thinking to deal with this aspect of digital elevation model ranking integration at pixel level and not as a unit area?
Well, that's another important point. As I just said, one has to be very careful when working with a digital elevation model on whether what you have at the specific location is really what you think is there. Because it could very often, none of these is 100% complete, and none of these is 100% perfect. When we do a ranking like the overall ranking, which we came up with in this paper, then essentially what we do is we say, putting everything in the big pot, what would be the best guess? And of course, that can be locally wrong, or it might have some caveats. But by and large, that's a statistically sound way to say overall this can be done. And unless you really want to look at the pixel level at things, there is a good chance that with this recommendation you will do well. If you are really interested in how things are at a pixel level, the problem there is essentially, if you really go to the individual pixel level, you don't have anything to compare to. How can you basically distinguish what is better and what is worse? It's relatively difficult. We were discussing that, and I still hope we can make a little bit of progress in that direction. But if you don't have any reference data, and in many parts of the world we don't, how can you at the very local level find out whether the collective elevation models that cover that area are good or are wrong, on which of them one is the better one and which of them is the worst one? Because you basically get probably slightly different values from all of them, and you have to essentially guess which one of them is giving you the closest one to reality without having any means to validate that. And that you could of course say, if out of these let's say, I think it's primarily 4 independent sources, 3 agree, then this is most likely the better value. If one of them is off, then this is probably the outlier. But if 2 are together and the other 2 are together, you're already in trouble. So it's not an answer. It's not a question to which there is an easy answer. It's really something where ultimately, with the help of maybe some further local statistics, you can rationalize how probable a certain slope or a certain derivative at some point is, and then eventually exclude certain DEMS for producing something that is not plausible, but also that can, of course, in theory go wrong. Is that more or less what you were asking for?
Yes, thank you. Yes, this is. Yeah. Perfect.
All right, thank you, Giuseppe. We have two more comments in the chat. Sam says that this is just amazing that you were able to accomplish so much. And I would add in the timeline, even if you didn't meet your initial ambitious deadlines, I think with like if I just compare with my own timeline on some of the projects, I think you guys did an amazing job in not a lot of time. And then the other Peter says we did pixel by pixel comparison just for certain slope classes, certain length covers, and so on. So it's a small clarification.
Yeah, maybe he wants to chime in and explain briefly. Peter? He has no mic. Okay.
Okay. All right. Do we have any other comments or questions? Doesn't seem like it. So I will just reiterate that the Geomorphometry conference is going to have a DEMIX session. And there's already quite a few papers published on this effort. So Peter in the chat encourages you to go read the preprint and download the different data sets. And I'm looking forward to the Geomorphometry conference in July so that we can hear more about this effort.
Yes, I hope to see many of you there. Yes, absolutely. Let me just put in the chat, because I think it was up relatively briefly. If that is wanted, I can put in the chat at least the two major links that we have in here, which is the one on the terminology paper of Peter. Here we go. And the second one that has the preprint of the paper. Oops. Here we go.
All right, thank you. So in the chat, you'll find two links to those papers. So I just want to raise your attention to the next coffee talk, which will be on June 7th. It's going to be Sebastiano Trevisani from Italy, from Venice, who will be talking about surface roughness analysis. Is there a need for standardization? So I think we're going to have another great coffee talk. I hope you can all join us to discuss surface roughness.
There is always a need for standardization.
Yeah. Yeah. So yeah, I mean, I don't know if Peter, you have a final word to share. If not, we'll end our coffee talk today.
No, it was my pleasure. If you have any questions on DEMIX or TMSG, feel free to contact me, and I'm happy to answer questions also via mail, and you're very much encouraged to come to Yashi, and I hope to have good discussions there, because to carry this activity on, we need further volunteers. This is all best effort. I mean, CEOS, the whole thing is only run by basically best effort, as is ISG, that the two have that in common. So it's really important that we join forces, that we work together wherever we can, and make the most out of the time we have. And there are good things ahead, and I think there is a lot of need for standardization for elevation models. We need to globally to get to reference models, to things that we share. I have a lot of discussions in Copernicus and in CEOS with about how we can essentially make that program more, let's say, bring that closer to users so that they can adopt these data readily, that these data fit to whatever they have, so that we make sure that when we work worldwide on anything that is geospatial, that these things fit together, and elevation is a key aspect in that. If we don't share our view on elevation, we have a problem in working together. That's the big item of interoperability on which we have to still put a lot of focus and energy to achieve that, and it's very necessary to solve the problems that lie ahead.
Great. Thanks for those last words. I will, so this coffee talk was recorded, and if you want to revisit some bits, it's going to be put on the Geomorphometry Society YouTube channel in the next few days. So I thank you all for coming. Thanks again, Peter, for this great presentation, and I hope to see you all in June for the next coffee talk. Thank you.
Thank you. Bye-bye.
Bye bye.
Bye, Peter.